In geometry, a frustum is the portion of a solid that lies between two parallel planes cutting it. A right frustum is a parallel truncation of a right pyramid. The term is commonly used in computer graphics to describe the three-dimensional region which is visible on the screen, the viewing frustum, which is formed by a clipped pyramid. In particular, frustum culling is a method of hidden surface determination. In the aerospace industry, frustum is the common term for the fairing between two stages of a multi-stage rocket, which is shaped like a truncated cone. It also applies to the essential drive element of the so far unproven M drive, elements, special cases, and related concepts. Each plane section is a floor or base of the frustum. Its axis, if any, is that of the original cone or pyramid. A frustum is circular if it has circular bases, it is right if the axis is perpendicular to both bases, and oblique otherwise. The height of a frustum is the perpendicular distance between the planes of the two bases. Cones and pyramids can be viewed as degenerate cases of frusta, where one of the cutting planes passes through the apex. The pyramidal frusta are a subclass of the prismatoids. Two frusta joined at their bases make a bifrustum. Formulas. Volume. The volume formula of a frustum of a square pyramid was introduced by the ancient Egyptian mathematics in what is called the Moscow Mathematical Papyrus, written California, 1850 BC, where A and B are the base and top side lengths of the truncated pyramid, and H is the height. The Egyptians knew the correct formula for obtaining the volume of a truncated square pyramid, but no proof of this equation is given in the Moscow Papyrus. The volume of a conical or pyramidal frustum is the volume of the solid before slicing the apex off, minus the volume of the apex, where B1 is the area of one base, B2 is the area of the other base, and H1, H2 are the perpendicular heights from the apex to the planes of the two bases. Considering that the formula for the volume can be expressed as a product of this proportionality alpha 3 and a difference of cubes of heights h1 and h2, only by factoring the difference of two cubes, we get h1 minus h2 equals h, the height of the frustum, and alpha 3. Distributing alpha and substituting from its definition, the Hieronian mean of areas B1 and B2 is obtained. The alternative formula is therefore Heron of Alexandria is noted for deriving this formula and with it encountering the imaginary number, the square root of -1. In particular, the volume of a circular cone frustum is where pi is 3.1415925, and R1, R2 are the radii of the two bases. The volume of a pyramidal frustum whose bases are n-sided regular polygons is where A1 and A2 are the sides of the two bases. Surface area for a right circular conical frustum and where R1 and R2 are the base and top radii respectively, and S is the slant height of the frustum. The surface area of a right frustum whose bases are similar regular n-sided polygons is where A1 and A2 are the sides of the two bases. Examples. On the back of a United States $1 bill, a pyramidal frustum appears on the reverse of the Great Seal of the United States, surmounted by the Eye of Providence. Certain ancient Native American mounds also form the frustum of a pyramid. Chinese pyramids. The John Hancock Center in Chicago, Illinois is a frustum whose bases are rectangles. The Washington Monument is a narrow square-based pyramidal frustum topped by a small pyramid. The viewing frustum in 3D computer graphics is a virtual photographic or video camera's usable field of view modeled as a pyramidal frustum. In the English translation of Stanislaw Lem's short story collection The Cyberiad, the poem Love and Tensor Algebra claims that every frustum longs to be a cone. Buckets and typical lampshades are everyday examples of conical frustums.